Hello and welcome to the new video, and this video is going to be about this particular fitting in ASHRAE Duct fitting database, which is SR1-1 Conical Bellmouth sudden contraction. Here we have this duct which has a width in the plan view, and here we can see its height in the elevation view or the side view, and also the plenum has a certain width and height. And this is connected to Plenum using some Bellmouth, and it has angle which is like constructed like both ways, which is like theta. And I have made this fitting in Revit here, this particular fitting which is SR1-1, and right now I have its two types, 30° and 45°. So I'm going to show you the calculation done with as per this software which is external to Revit. Alright, so and I will compare the calculations done by Revit and this software, because a lot of people, they just don't believe that Revit can do the calculations for every single fitting and everything can be done inside Revit. So here I have this air terminal, so I can enter any air flow value here, which will go inside this duct and through Plenum to this duct. Right now it is 3000 cubic feet per minute. I can change it to, let's say, 5000 cubic feet per minute, and you can see it has gone in both ducts 5000 and 5000, and I'm choosing right now this 30° angle. So what I'm going to do is that I'm going to input the same values of this duct and the plenum and the angle, everything. Right now it also has one parameter, which is the length of this tap, whatever you call it. So this is 4 inches right now, and I'm going to enter here. So let's say it is 18 by 10. So here it is height of duct, which is 10 and 18, and then the plenum is the same, which is 40 by 24. So 24 here by 40, yeah. And the angle is theta and 30°, and the length is 4 inch, and my flow rate is 5000. So just calculate. So here is my loss coefficient, and that is my pressure loss. Alright, so now if I select here, it is giving me this pressure drop calculation 0.15. Alright, and I have also all of these calculations going on. So if you can see, I mean, in this particular software you can see the loss coefficient table of every particular fitting. I have selected this one, and I can go to its view its previous loss coefficient table. So that's a complete table here, and you can see that it has these are the theta values, which are like 0, 10, 20, 30, 45 also. And then I have this AO by A1 and then L over DH. So DH is just hydraulic diameter, which can calculate easily for a round duct as well as for the rectangular duct. And now here I am in Revit, I am calculating everything. So inside the data you have here this A0 by A1, which is the ratio of the areas of the duct as well as the plenum. And so for the L by DH, which is here, this L by DH also getting calculated, and with this I am calculating this loss coefficient, and consequently I am getting my pressure drop calculation. Now interestingly, here I have chosen not defined, but still it is getting it's calculated. But this usually happens when our fitting has only 2 duct connectors, so we don't have to go to these pressure loss reports to verify that our calculation is done properly or not. We can visualize it right here because it has only 2 connectors, this particular fitting. Although in future I'm going to make a fitting in which there will be multiple taps here instead of one. There can be multiple taps, and I have to do that and post again, but that is for some later video, hopefully. So right now this is for the 30°, and right away I can select 45° here. So you can see that this angle gets changed from 30° to 40°. So this is 30°, and this is 45°. and consequently the 45-degree the pressure drop is getting updated 0.12. So if I just go here and in theta I just write 45-degree, so you can see that the pressure and the loss coefficient values are getting updated, changed, so which is same as of this 0.12. And I'll also have these values, like my loss coefficient is 0.122. So here it is, and this is super that was super hard to do, but still I managed to get it done. And now I have done it for 30-degree and 45-degree. Later on I'll have to do for 60 and 90 as per these tables here, which are mostly used. If someone wants like 10-degree, 20-degree, or even 120-degree, I can do it, and I can update the family. That's not a problem. But the thing is, this one is quite good enough to have it included with 30-degree and 45 degrees so far. Hope you liked it. Don't forget to like, share, and subscribe. Thanks. Have a nice time.